Okay, today we're going to see other kind of elements that we saw it the last time. We will see elements that are conservative and they are more than one port, namely the transformer and the gyrators. But also we need to see other elements such as the sources of effort and flow. So let's get started on this. On the source elements like SE and SF as we call them, you can see that clearly in here on the voltage of this circuit in here, input voltage of the circuit, the input is going to be the battery or source, and then the output would be a current over here. So that's that one. But in this case, on the suspension system, this is an interesting case because it's tricky to understand. When you go, let's say, on a suspension system such as a motorcycle, you go over the terrain. The question is, do you get a velocity input or a force input? What do you think? On a suspension system such as this, like could be for a motorcycle, what is the input? What's the input? Is it a force or it is a velocity? The logical thing is to say that there's a force because you go on a pump and then you feel it. I mean, that's, you say, oh, that came from the ground. But let's examine a little bit more detail what actually goes on. The suspension system follows the terrain, and as such, what's happening in real life, when you follow the terrain in time, isn't it true that you are making the system subject to the variation of the position, right? Yeah. So if you have a, like this, and you have a suspension system that is composed of this, like this. So isn't it true that the input here is a change in the position, right? As a function of time. But if this is true, the input in here is the change in the position. So the q dt is equal to the velocity input. So what happens is that the suspension system goes over a rough terrain. The tire has to conform to the surface, and in doing so, the position of the tire is depending on the velocity. Yeah, so the tire would follow, and then the input in this case is the velocity input, not the force. The force is the consequence, is what you feel. But first the input was a velocity input, because of our definition in here that the input is the change in position as a function of time. Said in other words, change in position as a function of time is velocity. It makes sense because the tire has to conform to a contour. So the input really is dy dt, is how much vertical connection we want. So this is there's the flow source on this case on the right hand side. this one, and then there is an effort source on the left hand side. Any questions about this? These elements are much easier than the C's and the I's. In this case, the effort source imposes an effort on the connected junction or element. The one on the right hand side is the flow source, and this flow sources impose a flow onto the system connected junction or element. Okay. Any questions about the difference between an effort source and a flow source? It's the same thing as saying a velocity source and a force source, or saying a current source and a voltage source. That sort of thing. Same thing. The Simulink representation of a effort source is seen in the pictures right there. The top is, you see, SE is the output. SE is the output in here, and SF is the input. This is represented this way, and this is represented that way. The two source elements that we need. Okay. It's very important that to understand that all effort sources will have this kind of causal form, and all flow sources will have this kind, because in the first case it is the force that is put into a system. In the second case, it is the velocity that you impose on the system. So, okay. I want to spend more time with you. I want to make sure that everybody understands this. The TF element is a conservative element used for gear sets. So it says two-port elements, they alter the magnitude of either flow or effort and transform elements. Transformers have a static relationship between the input, flow or effort, and the output, flow or effort, by means of a transforming modules. Best example of this is a set of gears, or this lever that is shown on the picture is actually a very good example. You're seeing here there is there's a way to express this. Perhaps I think it might not be a bad idea. We make some notes in there about that. Microsoft OneNote. Okay, so let's just do this tool over here and just say okay, it's gonna be just fine, and then you say draw. So in here we have, let's see, where are we? We need, yeah, we need the some place to write, and that's what I'm trying to do here. View, let's do this one like that. Okay, there we go. Let me just do it by hand, this explanation, to make sure that everybody is with me on this. Let's say this is the lever, yeah? And it has a pivot point. So if you apply a force over here, let's say F1, you need to maintain, this would be F sub 2, that's F1. If this is A and this is B, okay. In this particular case, for this to be in equilibrium, isn't it true that F1 times A is B times F2? Okay, so isn't it true that the velocity of this point, the velocity of this point so in this particular case, isn't it true that you say that the velocity v sub 1 is omega cross r? In this case, you say the velocity v sub 1 is omega times r. And this is the kind of equations that we need for this transformer. See, this is the yeah, omega is this. Yeah.
Which R? Like where's the R? The entire length or just the A?
Yeah, this is I should have just do the A. Torque is omega times, no, velocity is omega times the distance, in this case A. So V sub 1 is omega times A, like this. So is V sub 2 is omega times B. So you can say that V sub 1 okay, so there we have, this is the way to represent this. You say TF, and then in this side you have V sub 1 and you have F sub 1. I should say f sub 1 first and b sub 1 and f sub 2 and b sub 2. So the transformer is in this case R, yeah? Because you have that this is the yeah, b sub 1 or b sub 2 is equal to f1 over f sub 2. Okay, so having said this, this equation that you see here, this equation, okay, so you have this transformation. You write the equation, you write, if you connect this like this, you have that e sub 1 times the modulo R is equals to e sub 2. Ah, the distance is R is A, really. Yeah. So E in this case, E sub 1 is E sub 1 times R is equal to B sub 2. The other one is like F sub 1 let's go. So we have B sub 1 or B sub 2 is this. So if this is the case, you write the equations as E1 times, I see what you were saying. This we should put maybe another letter. Let's just put the letter M. How is that? So E sub 1 times M is equal to B sub 2 to E sub 2, and F sub 1 is equal to F sub 2 M times F sub 2.
I have a question.
Yeah.
For that B1 over B2, is that equals omega A, or is that omega A over omega B?
Where here?
Yeah, yeah.
Okay, let's take a look.
It should be A over B or B on the bottom.
Yeah, B1 over B sub 2 has to be, well, let's see. We have, this is right? And we have this is right. B sub 1 over B sub 2 is gotta be A over B.
Yeah. Yeah.
Okay.
Omega cancels, right?
Yeah, so this is the TF. I think we will take a look at the GY element next time, and we'll stop now.